Welcome, Algebra 2 students, to your last new material of this crazy spring semester. I have a joke for you, so just go ahead and take a minute and read this. I can't take credit for it, I found it, but hopefully this will make some of you laugh as you're reading through this and learning your last bit of new material for your year of Algebra 2 honors. All right, so hopefully you have your notes out for Unit 10, Day 2. In this lesson, we're going to be learning about permutations and combinations, which is a branch of statistics. I love this section, so if you have questions, please make sure that you are reaching out. So what I would like you to do is just take a minute, and I would like you to try the warm-up questions 1, 2, and 3. You don't have to know the answers right away, but I'm just curious to see if you're able to get them correct. At the end of the lesson, we'll come back to these and take a look at the answers. So just go ahead, take a minute, hit pause. And then try them, see what your math statistical skills are like, and then we'll come back to these at the end of the lesson and see how you did. All right, so the first thing that we're going to talk about in this lesson is something called a factorial, okay? And what a factorial is basically what we're doing is we're taking a certain amount of objects and we're going to be ordering them. So you're going to see this n, or any number with a factorial. That explanation point is a very happy number. Just kidding, very excited. So that explanation point is going to mean factorial. So what exactly does a factorial do? So if you were reading the questions on the previous page, they were kind of asking about, like, if there's 4 pitchers on the McLean baseball team, how many orders are there that we can put them in? Michelle has 5 friends from math class of 25. How many ways can she invite them? So what a factorial does is basically it's how many ways we can order a certain amount of objects. So for example, let's say that we had our 4 baseball players. Okay, when we do n factorial, that's going to tell us how many different ways can we order our 4 baseball players. So now what exactly does that explanation point tell us to do? So that's kind of like a mathematical operation, that explanation point. So what that explanation point is telling you to do is basically what you're going to do is you're going to take whatever number you have and you're going to multiply it from the biggest number all the way down to 1. So n factorial means you're taking n minus 1 is the number 1 less than that, n minus 2 is the 1 less than that, all the way until you get down to 1. All right, so it's easier to see with an example. So 4 factorial basically means that I'm ordering 4 different objects in 4 positions. So that's like saying I'm taking 4, n minus 1 is 3, n minus 2 is 2, and minus 1 is 1. So basically what I'm doing is I'm multiplying 4 times 3 times 2 times 1. So you start at the biggest number and multiply every single number out down until you get to 1. So in this case, it's just going to be 24. All right, now notice what I did here is I have little lines here. So for factorial is, I've already said this, is you're ordering a certain amount of objects in a group. So this is like saying I have 4 objects and I have 4 positions. So I have position 1, I have position 2, I have position 3, and I have position 4. It's like saying I have 4 objects to put in the first position, 3 objects to put in the second position, 2 objects to put in the third position, and 1 object to put in the fourth position. How many different ways can I position those objects? Okay, and we'll talk about that more as we move on. All right, 7 factorial, so you'd start out with 7 and multiply all the way down to 1. So you do 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, multiply that out on your calculator and you're going to get 5,040. Now, what I would like you to do is I would like you to take a minute and try 15 factorial and see what you get for your answer. All right, so go ahead and hit pause if you want to try that, and then check out my answer once you're done. Okay, so you should have taken 15, multiplied the largest number, okay, all the way down to 1, and you should have gotten an answer of 1.308 times 10 to the 12th. Okay, so on your graphing calculator, I'm going to show you what that looks like. So it can get kind of tedious to write out 15 all the way down to 1, but the nice thing is our calculator will actually do this for us. Okay, so our calculator has that factorial button on it. So what you're going to do is, remember your calculator is only as smart as you are. So think about what you're doing here. You're doing some math. So since you're doing some math, you're going to hit the math button. You're going to hit the math button. Now, in this section, we're dealing with probability, so we're going to go over to probability. And notice number 4 is that factorial button. So you're going to go down to number 4. Okay, and I actually had my answer factorial, and that's going to probably give me some crazy number. So you want to make sure that you actually type in your number first. So hit 15. Some of your calculators might not have to do this, but mine, I type in the number first, math. I'm dealing with probability, and then I'm going down to number 4 and hit enter. Now notice 15 factorial looks exactly like it does on your paper right here, and you hit enter. Now it gives you 1.0376, so we just rounded to 8. E to the 12th means times 10 to the 12th. Okay, so anytime you see that e to the 12th, it means times 10 to the 12th. On your calculator, it looks like e to the 12th, okay? It's not the letter e, it's just saying times 10 to the 12th. So your calculator steps, now you may or may not have to do this, is basically you're typing in your number, okay? And then you're going to hit math, and then you're going to go over to probability. You're going to go down to number 4, okay, and then you're going to make sure you hit enter. All right, and that'll give you your answer for you. You don't even have to do it by hand, okay, and you can use your calculator throughout this lesson to help. All right, so what we're going to look at next is we're going to look at something called a permutation or a combination. So in the previous example over here, basically we were saying that we have a total of 7 objects, and we are putting 7 objects in 7 positions. So think of it as like I have 7 people in 7 chairs. So what I can do here is I'm basically like saying I have 7 people I can choose from for the first chair, 6 people I can choose from for the second chair, 5, 4, 3, 2, 1. Well, if I have 7 people in 7 chairs, why can't I do 7 times 7 times 7 times 7? Well, the reason for that is because on my first one, I've used 7, I have 7 people to choose from. I've physically put a person in that chair. How many do I have left for the second position? Well, I only have 6. Now I'm putting someone in that chair. How many people do I have left for my third one? I've already used 2, so I only have 5 people to choose from left, all the way down to the bottom. And we'll be explaining that more as we go into this lesson. Now, let's just take a minute and look at the next question. The next question says, how many ways can we seat 4 people in only 3 chairs? Okay, so how can we seat 4 people in only 3 chairs? Now, this is different than 4 factorial. Why is this different than 4 factorial? 4 factorial would say I have 1, 2, 3, I have 4 chairs. And in the first chair, I can put somebody. Now, remember I had 4, 3, 2, 1 people to choose from. I've already chosen someone. So in the second chair, I have 3 people I can choose from. In the third chair, I have 2 people I can choose from. And for the last chair, I've used everybody, so I only have 1. Okay, so that would be 4 factorial. Now notice here, I only have 3 different positions, okay? So I have position 1, position 2, and position 3. Now I want you to think about how many people you can put in chair 1, how many people you can put in chair 2, and how many people you can put in chair 3. So label these chairs as chair 1, as chair 2, as chair 3, and I lied. Don't label them as chair. Label them as person 1, person 2, person 3, and person 4. Okay, so what I would like you to do, you have 4 people. How can you arrange those 4 people in 3 chairs? So I'll do the first 2 with you, and then you're going to try these on your own. So for example, I have person 1. Okay, then I can put person 2 and person 3 next to it. Then I can put person 1, and then I can put person 3, and then person 2, and then I can put person 1, person 3, and person 4. Okay, so basically, what are all the possibilities with person 1 being first? What are all the possibilities with person 2 being first, person 3 being first, and then person 4 being first? So go ahead, take a minute. I'd like you to try setting this up, see how you do. Please hit pause in the recording and see if you can get the correct number of arrangements. Okay, this is specifically talking about arrangements, the correct number of arrangements can you come up with, okay? So, and in this case, the order in which they're sitting matters. So I have, basically notice I have 3 people here. Person 1, person 2, person 3 is different than person 1, person 3, and person 2. So go ahead and take a minute and try that. All right, so I know this might have taken you a hot second or two to finish. So hopefully you figured out that there were 6 different combinations for each of person 1, person 2, person 3, and person 4. So basically we were saying in chair 1, I had person 1 first, and then I had person 2 first, and I had person 3 first, and I had person 4 first. And then what are all the possibilities with person 2, 3, and 4 in chair 2 and 3? So there's a total of 24 different arrangements, okay? Now, that's kind of time consuming to do, is to write out all of those different arrangements. I don't want to do that every single solitary time. So let's take a minute and we're actually going to figure out 2 other ways to do this, okay? The first way that we're going to do this is making a tree diagram. So basically when you make a tree diagram, the headers of your tree diagram, those are going to be your positions. Okay, so think about in my positions, I had chair 1, I had chair 2, and I had chair 3. Okay, so I have 3 different positions that I have. Now let's think about chair 1. Okay, in chair 1, what are the various people I can put in chair 1? Well, in chair 1, I can put person 1, or I can put person 2, or I can put person 3, or I can put person 4. Okay, so I have 4 different possibilities that I can put in chair 1. Now, let's assume that in chair 1 is person 1. Okay, so now what are my possibilities? The branches are your possibilities for chair 2. Well, I've already used person 1, so person 2, 3, and 4 are the only possibilities I can have for chair 2. Now, let's think about chair 3. So if I had person 1 and person 2, then in chair 3, I can only have, let me erase this. Okay, I can only have person 3 or person 4 because I've already used 1 and 2. So now if I've used 1 and 3, okay, it doesn't really look like a 3. So here I've used person 1, I've used person 2, so in chair 3 my only possibilities are person 2 and person 4. All right, so chair 1, okay, I've used person 1 and person 4, so for chair 3 my only possibilities that I have are 2 and 3, and this could keep going. Now what I want you to think about here is at the end of the branches, what does this mean? So if I kind of go across the whole end of this branch, this tells me that in my position I have person 1, person 2, and then person 3. So think about that. That's person 1, person 2, and then person 3. So if I go across this branch, I have 1, 2, or sorry, that's a 3, 1, 3, and 2. So that branch was 1, 3, and 2. That's this branch right here. Okay, if I wanted to go 1, 2, and then 4, that's that branch right there. Okay, so this can also get a little bit time consuming. So then in chair 2, so sort of think about this, how many different possibilities will you have for your second chair? You would have the possibility of having person 1, person 3, or person 4, and then how many would be off of each of these? There'd be 2 off of each of these. Okay, then you do the same thing with 3 and the same thing with 4. Well, let's think about how many branches are at the end of each of these. At this branch right here, there's 1, 2, 3, 4, 5, 6. So there's 6 possibilities with person 1. Then same thing's going to happen with person 2 in chair 1. There's going to be 6 all the way at the end. So I have 6 possibilities here, 6 possibilities with person 2 out front, 6 possibilities with person 3 out front, and then 6 with person 4 out front. So that gives me a total of 24 possibilities. All right, and then in our next portion, we're going to learn about how we can do that another way if you don't like the tree diagrams or writing everything out.